Hi everyone, this is the third video on the ACT Math Practice Problem series, and here again we have another nice little problem from the Laws of Exponent. And as I always recommend, before seeing the solution, please give it a try to solve it by yourself, and then finally you can match with my solution. Now let's look at the solution here. Well, we have a nice little binomial which is a minus 5 with an exponent of negative 50, and from the laws of exponent, the only thing that comes to my mind is that this is like a to the power negative m, right? If you assume that we have a quantity with a negative exponent, so I can think of it like this, that this must be equal to 1 over a to the power positive m. That is the only property from the laws of exponent that I can think of at this moment. Now this must be then equal to 1 over a minus 5 to the power 50. Now if you look at the options, we have option D, which is pretty close to this one but not quite exactly. It's pretty close. None of the other options are not even close to this thing, right? So then we probably have the option D as the correct option. Now how are you going to prove it? Well, I have intentionally added this one extra twist here. So suppose from here, can we write it like this? It would be 1 over 5 minus a. I am intentionally making it 5 minus a. So whichever was the positive term, I made it negative, and whichever was the negative term, I made it positive. So that means I then also have to multiply by a negative 1, because if you multiply negative 1 with 5 minus a, this will become a minus 5. So the a minus 5 has been written like this, and now I am going to use the exponent on top of this entire thing. I am now going to use the exponent 50 on top of this entire product here, right? So then from here, what can we say? Well, this must be equal to then 1 over, we have 5 minus a, exponent should be 50, and then also negative 1 with an exponent 50. Now why is it like that? Well, you know the property of exponent which says that if we have a times b whole to the power m, then we can write it as a to the power m times b to the power m, and that's exactly what I did. We had this one quantity here and another quantity here, and they both had the same power and they are in the product form, so they both have the same power. So we said, okay, then let's separate them. So I just simply applied the exponent to each of them. They are still in the product form, but I applied the exponent to each of them, right? So then from here, what do we get? Well, we get 1 over 5 minus a with an exponent or power 50, and also we have 1 over negative 1 with a power 50. Now you must be familiar with the fact that if you multiply negative 1 an even number of times, I mean if there is an even power of negative 1, it will give you positive 1. How? Let's take a look. So suppose you have negative 1 squared, for example. What do we get? Well, this is actually negative 1 times negative 1. That is again positive 1, because negative times negative, that becomes positive. If we have negative 1 with a power 4, what do we get? Well, again it will be negative 1 times negative 1 times negative 1 times negative 1. So if you take two of them together, these two will give you a positive 1 and the other two will also give you a positive 1. So this is essentially a positive 1 times positive 1, which is again equal to 1. So no matter what is the power, as long as the power is an even power, even number, right, your value will always come out to be positive 1. So here if you think about it, in our example here we have negative 1 power 50, and 50 is an even number, so the power is even, so this will give us a positive 1. Then what are we going to get? Well, we'll have 1 over 5 minus a whole to the power 50, and then times we'll have 1 divided by this becomes a positive 1. The negative 1 to the power 50 becomes a positive 1. So ultimately what we got? Well, ultimately we got this is 1 over 5 minus a to the power 50, and that means D is the correct answer. I hope everything made sense. Thank you for watching. See you in the next video.